Good afternoon, everybody. Good morning, good evening to all of you from wherever around the world that you are joining us today for the rescheduled webinar of yesterday. Thank you all. Thank you all. Thank you very much. We're going to start the session right away. Once again, I would like to apologize for all the technical issues that we encountered yesterday. This is what has necessitated a rescheduled session that we are holding today on Sunday. Very unusual, but that is what we had yesterday. We apologize very profusely. So on behalf of BENA Maintenance and Reliability Services and our training arm, the BENA Capability Academy Africa, we beg for your forgiveness again. We pray that we don't have any of such hitches today. Today's session will be approximately 90 minutes, 1.5 hours. Could be a little more or a little short. As we start now, every question that you might have, that any one of you might have, please type questions in the question and answer pane. Do not put questions in the chat pane. We may not see these questions during the sessions. So any questions pertaining to the presentation topic, put in the Q&A pane. Any other question or statements or greetings, whatever, pertaining to connectivity, loss of voice, anything else, put in the chat window. Thank you. Not many people are here today, right now, but we will start nonetheless because time has gone. So, our company is currently testing the LMS system, like I have mentioned in the last webinar session. We're testing this in the back end and working very hard to see that by the end of July at latest, we put this thing online and people like you can go onto our website, our learning management system, sign up, buy a course and attend the course all by yourself and all virtually from anywhere around the world. So we're trying very hard to give you the best experience that you will get online on the learning management system. As usual, all our company social media handles are behind each of the respective icons. So if you can see my cursor, the channel address for YouTube is here, that for Facebook, the handle for Facebook is here, Twitter, LinkedIn, and Instagram. So I will need you all, if you can, right now, go to any of these social media apps and search and follow us if you can. But if you cannot, then you can do it right after this session ends. Today's presentation shall be handled by a very good friend of the house, very good friend of the house, one of our latest certified reliability engineers, ASQCRE, very brilliant guy. He's reliability analyst with Chevron, Nigeria. His name is Aziz Abiodun Olaniyan. He is a man with many qualifications, many certifications. He has earned the CMRP, the CRE, the CVA, level 1, MLA, that is lubrication analyst. And then, of course, he's a certified ultrasound testing technician, level 1. So the contact details of Aziz are here, as usual, like for all our previous trainers. Email is here. His LinkedIn address is here. His Facebook link here. And of course, his phone number is here, and this phone number is also available on WhatsApp. So you can chat him up anytime that you feel you need any assistance whatsoever. So at this point, I will be handing over to Aziz to take control of the system and make his presentation. So Aziz, if you can hear me, please take control. Can you hear me, Aziz?
Thank you, Malam. I can hear you loud and clear. Good afternoon, everybody. Yeah, as rightly said by Malam, my name is Aziz Abiodun Olaniyan. I work for Chevron Nigeria Limited in one of the deep water offshore as a reliability analyst. I have 10 years plus experience with Chevron. So we'll be talking this afternoon on reliability opportunity, defect elimination through bad worst actor investigation process. When you hear reliability opportunity, this is basically trying to identify the reliability opportunity in our rotating equipment or products, those opportunities that are cost effective, that can actually improve the performance and reliability of our rotating equipment in our various assets. Defect elimination through bad actor worst actor process is a very, very good tool that we use as a reliability engineer or analyst or technologist in oil and gas. At the end of today's presentation, I want everybody to sit right and actually relax. You are going to get a lot of information here today. Before I go further, I have basically 4 outlines here that we will be discussing on this afternoon. Definition of key terms, reliability starts with people, defect elimination, and the main topic itself, bad actor, worst actor investigation process. The first 3 topics, before the real presentation, we actually need them to be able to actually understand what this bad actor, worst actor stand for. Definition of key terms, failure. That is the inability of an asset to perform one or more of its intended function. In our various facilities, we want to believe we have so many components, we have so many equipment that are actually designed for one function or the other. You say it has failed if it cannot perform that function with which it was intended to do. Let me quickly bring my annotator. Look at this electronics panel, got by fire. This is a typical example of a failure. It has failed because as it is, it can no longer perform the function with which it was designed. It's glaring that it's failed. The other good example here is a bearing here. This bearing and half, you can see that it has inner race failed already. As they are, they can no longer perform their function. This is a typical example of failure. Now, what is function? This is the purpose with which an asset is designed. You know, it is first designed by the OEM, but in most occasions, we have a case where the user redesigned it. Take for instance now, I have a phone, if you have a Samsung phone, that the function of the Samsung phone is for it to work for you to make a call. The Samsung phone is expected to make a call. If you lose the screen, for example, it does not mean that it will not perform its function because you lose the screen. It can still make a call with it. There are primary function and secondary function, which I want to bring out here. For people that work in oil and gas and those of us that work with pump and compressor, if a pump is installed to perform a particular function, what is that primary function of a pump? The primary function of a pump is for it to increase the pressure of the liquid, to increase the pressure of the liquid. Then the secondary function of that pump, it should be able to retain the pressure. Another good example I want to bring to light here is people that actually do what we call centrifugal injection compressor in oil and gas. This is the compressor we have that is used to inject gas into the oil well. My colleague in the house that I've worked in oil and gas will actually understand better what we call centrifugal gas injection. It has a seal. The main aim of that seal is to provide a sealing effect. The seal is a component that has what we call inner labyrinth seal. The inner labyrinth seal is located at the inboard of the seal. What is the function? The function is to kind of prevent the processed gas from getting into the seal itself. At the wall of the seal, we have what you call another seal, which is called barrier seal. That barrier seal is to protect the lubrication oil from the lube oil tank into the seal itself. So the seal has a primary function of providing a sealing effect so that we will not have the process seal getting into the compressor itself. And at the same time, the other side, we have a barrier seal, which is to prevent the lube oil from getting into the compressor sealing system. So these are secondary functions. So we should be able to perform, the seal must be able to perform both the primary function and the secondary function. There are key important terms that I want you to take note here, which we use in biodata investigation: failure durating and failure no durating. What is failure durating? We have so many failures. There are three basic failures that we can experience with our pump, with our compressor. It's that when the component fails, the failure will not actually affect the function of that equipment. And we have a case where we have a failure, and the particular failure that we experience will actually affect the function of that equipment. Okay. The first one I have to explain here is an unplanned failure of a component or subsystem which can deprive the system from performing its original function. This is called failure durating. A failure at the same time is that failure that we experience that it's actually of that particular equipment. Take for instance now, we have what they call utility air compressor. Utility air compressor is what we need we have it in our facility, and I want to believe everybody that has what they call utility air compressor. What does it do is to kind of provide a dry air into the facility. These are the dry air that our transmitter need to get function properly. Now, I have 3 compressors, for example, and I need 2 at a go. That is a system. Compressor A, B, C, I have 3 of them, but I need 2 for my optimum performance in my facility. If I have a case of maybe the compressor bearing bad in one of them, because I still have to work it, so in that case, that is failure no durating, because it has not actually affected the system. Though I have a failure, but I have 3 of them. It's only one that is done due to a failure. So, but I still have 2 remaining. That is failure no durating. But in a situation where I have 3 compressors that are supposed to be available for my optimum performance, 2 are done. Okay, and I have 1 left, or 1 in that I have 2 left. If I have a particular failure on the other one, which will not make it available for me to have 2 at a go, that is failure durating. Take note of all this, because in the bad actor analysis, we are going to be seeing more of this. Then the other terminology that is very key to bad actor analysis process is proactive repair. Proactive repair is the PM strategy that works to correct the root cause of a failure and avoid that failure, avoid the failure. As a reliability analyst on board, we have so many PDM strategies, PDM that we use. We have vibration analysis, we have ultrasound analysis, we have lube oil analysis. So if I carry out a lube oil on a particular piece of equipment, a pump, in the course of my doing PDM, I find a defect in the way analysis. That defect means that this machine cannot continuously running, or we have to kind of carry out the root cause of that particular defect. What I need to do, raise a work order. I raise a work order to mechanical guys, go and check. I begin to see some particles coming from my pump, and that is likely the bearing. I will know that it's a bearing after carrying out some tests to actually know the particle, the material of that particular particle that are found. So that is proactive. In this case now, the mechanical guys will quickly go there, bring the machine down before it fails and get it done. We have worked proactively. You can see the maintenance guys smiling here, smiling because we are able to cut it before it actually affects us. Then investigation is another key terminology that is very important to this what startup bad data process. We are going to see more of this as we go along. Investigation is simply a process of understanding key attributes of a particular failure with a view to identifying the likely cause of failure. Okay, it's very key to identifying. That is the main reason of why we are investigating. We are investigating to actually know why do we have that failure. We are not investigating to know which particular technician actually work on that piece of equipment. We are not investigating to know which particular operator did not operate that particular equipment very well, but rather we are investigating to know what is the cause of the problem with a view to actually correct it and ensure that we don't have the same kind of problem in the future. That is investigation. And this guy you see here he happened to be a reliability engineer trying to investigate the problem. Now, the other important key terminology that I want us to talk about is defect. Defect is simply non-conformance of the unit of a product with the specified requirement. Look at this chain as an example here. This guy, this is ash color. The other one here, red color, that's broken. This is a defect. It's clear. This is a defect. Okay. Then we have another one here. This happens to be like a roller bearing. We have about 7 balls. We have 7 balls here. So these 7 balls, one of them is bad. If one of them is bad, this particular bearing can no longer perform its function again. This is a defect, and this is it has failed. I want to bring something to light here. Defective. Defective is a unit of product which contains one or more defect failure to meet requirement of stated function. Defective is a unit of product which contains one or more defect failure to meet requirements of stated function. Let me use a phone, a Samsung phone again as an example here. Several times we have a case where our screen, the screen of the phone, got broken. You don't like it, but that is a failure because you have the screen broken. That is a failure. But your phone, you can't say it is defective because you can still use your phone. You have a failure, but your phone is not defective. Another good example now is that in my facility, we have so many pumps. We have pumps that are seawater adjacent pumps. We have one that are gas turbine compressor. We have gas turbine generator. We have air compressor. So many of them. Then there are vibration probes that we install in all of these forms. What are they supposed to do? To kind of serve as a protective device. Okay. If I have 2 vibration probes, for example, installed on the hardball of a bearing of my pump, 2 of them, and 2 of them must fail before I will say that my bearing is bad. But if I have one of them actually bad, that is a defect. But since my bearing is working perfectly the way it should work, so I won't say my bearing is defective. It's not defective, but I have a failure, but the bearing is not defective. I hope you are following. Now, definition of key task continue error. Error is something done or an event which is considered to be wrong or incorrect. Okay. You can see this drawing here. If this person actually makes an error, he makes an error, the error caused this defect, and we have this failure in operation. He commits an error. The error results through a mistake. He commits an error. The error results in defects of the software, and we have a problem here. So in most cases, you find this error coming from a machine through the mistake made by man. If I have a case where my probe, a vibration probe that is installed to monitor the vibration of my bearing, normally there are some standards set by the OEM that the probe probably should not be more than 20 microns. You know, if it's getting to 30 microns, for example, that's an alarm. If you get to 35 microns, for example, it shuts my machine down. So if I'm operating between 15, I'm now operating around 1 microns or 2 microns. It's too call for a concern, because you won't say because 2 microns is lower than the value with which are supposed to run a KPI. It's an error because it's an abnormal condition. What is defect elimination? It implement corrective to prevent future similar failures. Underline this word: to prevent future similar defects. That is the main reason why you want to eliminate defects. That is the main reason, to prevent future similar defects. You analyze the defect, you identify where is that root cause is coming, then implement corrective action. A good example here is that we have so many maintenance technicians probably registered for this webinar. We have production maintenance supervisor, we have operation supervisor here that are registered for this webinar. So in the case where maintenance technicians say there's a problem, or operator say there's a problem, maintenance technician will quickly go and fix the problem. You don't fix the problem, but rather you investigate what is the cause of that problem. The problem, the bearing failure you see might not necessarily be the root cause of that pump. Okay, you might have a case where the lube oil that actually supposed to lubricate the bearing, the lube oil line is bad, or we didn't use the correct lube oil, so that we are actually expected to actually carry out the real investigation on the main root cause of why we have a particular component fail. So this is defect elimination. We are going to be using a lot of these in the subsequent slide. Then the other one I would like to bring to you people is the equipment criticality analysis, ECA. You know, this is kind of a criteria that outlines the potential consequences so that they can be evaluated, categorized, and prioritized. The key word there again: evaluate, you categorize, and prioritize equipment criticality. You want to agree with me, for every equipment that we have in our facility, we cannot count all of them as critical equipment. All of them cannot be C1 equipment, but rather we have to know which one of them we actually need for the optimal performance of our operation, which one of them that if we don't have them, we'll still perform, we'll still do what we're supposed to do. So this is the reason by which we should carry out equipment criticality analysis. As we go forward, we are going to learn more of that. Then there are key steps of ECA. Step number one is we have to agree on the risk matrix. Assemble your equipment asset hierarchy, then assess the failure risk associated with each of these assets. What is agreeing on the risk matrix? Now, the first step before you can carry out the equipment criticality analysis in your facility or anywhere is to ensure that every corporate have their own risk matrices. The local management, for example, where I work, I have my local management, I have ORM, that is the offshore installation manager, I have my maintenance chief, I have my operations chief, because the maintenance superintendent and operations superintendent, then I have some other leaders that are supervisors. So what I agree on the risk matrix I'm trying to say here is that what is the risk matrix to the upper management might not be the same for my local management. If I have an NPU, that is lost production of 1,000 barrels, probably that 1,000 barrels might not be a big deal to the upper management. But my local management might say that 1,000 barrels is a big deal to us. So we have to agree on that. The other one is assemble your equipment asset hierarchy. What is equipment asset hierarchy? This is very key before you can start your equipment criticality assessment. In every facility, we have a lot of process. From the processing, we have a lot of pumps. The pumps, they have the components, different components or items of those pumps. You have to kind of assemble them in that order. Where I work at BioFSO, for example, is an asset. Then when I get at BioFSO, we have so many processes, like a gas turbine. We have a gas turbine compressor. We have a gas turbine generator, and so many of them like that. Okay. Then we have to kind of segregate them before we can be able to carry out equipment criticality analysis. Then the third one is assess the failure risk associated with each of these equipment. Look at this matrix, look at this table I have here, probability of failure and severity of failure. If I lose my utility air compressor, if I lose it in case it's not available, for example, what are the severity that is going to cause me? So we begin to analyze that. Okay, if I don't have, I'm supposed to have my two utility air compressor to provide dry air. If I lose that, it will actually be difficult for all my transmitter in the field for them to get dry air. If I can't get dry air in my facility, on my transmitter, they need to cause a lot of shutdown. So it will affect my control system, it will affect my production, a lot of things will go back. So from there, you need to tie them one by one. Now, the next on this slide is reliability starts with people. The reliability starts with people. Look at reliability is sitting on four major elements here. Equipment is number one. Number two is process. Number three is people. Every one of them are sitting on top of design. So what do I mean by reliability starts with people? Equipment. Normally, you want to get a equipment from correct OEM. They know what they are doing. They actually put everything in the right standard. They know what is supposed to be per design. Then process. After installing the equipment in our asset, we have different processes. Preventive maintenance from the maintenance we have corrective maintenance, we have breakdown, we have put in by people. The equipment was installed by people, okay? The design, again, the designer, the reliability engineer would have done what he's supposed to do. The quality control engineer would have actually done what he's supposed to do. The engineer that's supposed to design that particular pump have done what he's supposed to do. Done by whom? By people. Now, what I mean by people is that with people. There's none of these elements that do not involve people. During the installation of equipment, we have people. Then the process that we put in place, who are the people that will implement it? Is the same human being. The design that was done by who? By people. So it is very key that the people that we are going to gather to get this done, they actually know what they are doing and actually do what they're supposed to. Even though when during the operation of the equipment in the facility, we have the operation, we have the maintenance, the operation will be able to carry out the ORD. What is ORD? Operation routine duty. Who are they? Human being. Are they prone to mistake? Yes. Are they prone to error? Yes. So people is very key. So when you talk of reliability, the main person that is actually vulnerable to defect is people. So you should get this in our mind. Now, getting the right result the right way, we have to work on people. You want to get the right result in the right way. It means that we have to gather people that have right attitude, people that actually qualify to do what they're supposed to do, people that actually they have gone through several training to actually know what it is versus what is supposed not to be. People that actually, know that OEM specification is very, very important. Then you cannot do it with attitude. If you have people that actually know what they're supposed to do, they have correct attitude. What about their attitude to work? How is their integrity? Are there people that will say that, hey, I did it, it's my mistake? Are there people that always argue with you? I need somebody that at least ashamed, of accepting a mistake. So all these things are very, very key. Then the third one, people that have right altitude. What I mean by altitude here? Of course, yes, there are deliverables that we employ a reliability engineer. Okay, do this for me. These are your deliverables. But this reliability engineer or reliability analyst or reliability technologist, as the case may be, is supposed to know that you should go beyond what you are actually employed to do. You have right altitude to actually satisfy your goals. You want to go beyond what is expected of you. So all these three key important factor matters. People, some of us that are here that are in charge of labor employment, a lot of us here are production manager, a lot of us here are in charge of maintenance operation. You should please take note of this. A lot of training are here now and around with behavioral reliability to ensure that people are actually guided on the right path. Because if you want to say that people that have BSc or HND or Masters or PhD or Professor in engineering, for example, in our conventional university, you can't get to learn all these things that we're talking about concerning where do we supposed to put our equipment before we can get the right result. But rather, there are some professional training that people need to go through, in getting their understanding about what is expected of them, be able to relate with their colleagues everywhere in the globe. Reliability now, everybody talks about reliability. So reliability, we've realized that we need to get things done in a proper way so that we keep, continuously running. At the end of the day, to eliminate defect, and at the end of the day, it will be cost effective, and at the end of the day, we'll produce more products or produce more product. Now, look at what this guy is saying, complaining, criticizing. It is not me. It is that mechanical technician that did it to, it's the electrical technician that did it to, no, it's operator. So this is not where we're supposed to be. This is not normal in an asset. What concerns everybody is this has to be done the way it's supposed to be done. If you see it, it belongs to you. If you see it, you own it. Reliability is about everybody. It doesn't belong to only mechanical technician. It doesn't belong to only reliability engineer. It doesn't belong to only operation or control or instrument, but belongs to everybody. So criticizing, complaining, condemning is not it. Right people with the right skills in the right place at the right time, we actually achieve the optimum reliability. Yeah, defect elimination. This is a culture, like I said earlier. So it's not a job of, it's a job designed for the OE, O&M, that is operation and maintenance team. It is expected that every functional staff, underline the word functional. It means everybody that is employed to do one or two things in an asset, in an organization, has to think about defect elimination. It's supposed to be a case where we have people that an asset unit, they are working in the facility. As they are working, they are so attentive to know that, how is this machine performing? How is this compressor doing? How is this pump doing? They want to use their sense of hearing. They want to use their sense of smelling. They want to use their sense of sight. Every time they go, they want to see, this noise is unusual. This is not what it's supposed to be. You will not say because I do not belong to reliability unit or I'm not a mechanical technician, my job is a painter, my job is just a rigger. As long as you work in a facility which is supposed to come as your farm, because that is where you make your money, it actually means that whatever that happens to that facility concerns you. It could be safety related, it could be total failure, it could be anything. So it means that defect elimination process involves everybody in the facility. I just use as an example, look at this thing, you are trying to investigate, maybe you are going, okay, why is it happening? Maybe you touch a particular thing and you see it. So if you see this, you call the attention of an operator. Then, in defect elimination process, every employee should be actively engaged in the defect, process. I've said that before. Identified defect must be removed from its root. Underline, from its root. It must be from its root. You find a defect. Defect, it could be a symptom to what is happening. If I'm hearing a noise, okay, my bearing is making noise. Why is that bearing making noise? Will it be a problem from the low boy? Will it be a problem from one of the ball? Is it an inner problem? or cage problem. So you should be able to investigate so that you eliminate it from the root. Then a good system operated defect elimination process needs to be established. I said it earlier, it has to be established in the sense that whether mobile platform, SharePoint platform, shared platform, or any of these platforms. I'm using the example of oil and gas because, as you know, I belong to oil and gas. But I want to believe that whatever that is here, anywhere we have photo equipment, even though people in the food industry, we have a lot of equipment that we don't want them to get spoiled we don't want them to get failed before we spot the problem and repair them. So you have to kind of establish a system where everyone's going to be involved. You involve everybody. Now, look at this chart here. So you discover a defect is discovered at this point. Now, is it an emergency problem? If it is yes, you go to my right on my screen, you notify operation and maintenance immediately. It's an emergency. Then the maintenance man will provide the recommendation of what do I need to do. Okay, do I need a reliability engineer? Yes, the reliability engineer will review the situation. Or no, if it is no, then you generate emergency work order immediately. The emergency work order to perform the work. Now, come to my left on my screen here. If the job, the defect that you find is not an emergency, if the answer is no, you create defect record immediately. You record it for reference purposes. The team will review it. They will convert to work order record. Convert to work order record. Here is very key. So I'm going to be talking more on this in my slide. To convert to work order record is very important. You raise a work order. You raise a work order. The operation man, my operation friend will just say the pump failed to perform or is not performing according to its function. That is what they will say. But as a maintenance guy, on getting there, when you are about to do your job, you have the responsibility of trying to verify what is the actual problem. So in the problem description in that work order, the CMS, you change the problem description to the actual problem you find in the field. Very, very key. Very, very key. Take note of this, we use in the future. Now, work order is planned and scheduled. You perform the work, you update the CMS, and you close out the work order. Updating CMS, I'm going to talk on more of this. And as we go on. Now, study have shown failure are generated from three major sources, which are aging, basic wear and tear, careless work habits. Aging, when you say aging, in most cases, the failure is as a result of a long-time period of asset use. Asset within the category can show defect, even if not operated at all. So aging is generally seen as the lowest reason why equipment fail, aging, because we've seen cases where even though you don't use the equipment at all, if you put it down, whether you use it or not, it can fail, So aging is seen as the little of all the reason why equipment fail. But basic wear and tear, failure of asset within the category of shorter period of time depending on the equipment quality. So wear and tear is the major reason why you want to carry out PM. On this job, we have monthly PM in my facility, we have quarterly PM, we have yearly PM, depending on the criticality of that equipment. The word criticality is coming on again. How do you know your equipment is critical? We said it earlier. Then the careless work habit, this is where people, come to play again. We have careless work habit. Work habit, good attitude, and good attitude. Integrity of a worker. You want to see a personnel that will do something and say, my boss, it's my mistake. And as a boss, of course, you don't say because somebody have come to you and say you made a mistake. You don't want to punish because he has come to that, made a mistake. Rather, find why do we have that mistake. In recent root cause analysis that we do in our facility, human error, is not going to be the major, it's not going to be seen as a root cause again. So, but rather, what can you do to eliminate human error? Okay. A man made a mistake, for example, an operator made a mistake from actually topping up. Why did he make that mistake? Is there any other possibility? Is there other reliability opportunity around that make us to improve it so that the man will not make a mistake? Those are the things that we should be looking at. So these three aging, basic wear and tear, careless work habits are very key, in defect elimination. Then look at this chart again. I normally discover at PDM, what is PDM? Predictive maintenance by technician, maybe during vibration analysis on a pump, you see a high 2x. High 2x means misalignment, okay? You have a work order to quickly remove it, to perform the repair so that I can remove that, come to the repair. The repair was performed and defect eliminated at this stage. This circle is there to show the plant facility operation, and we have an ongoing maintenance continuously like that. As we have this in place, defects caused by aging, I've said earlier, just 4%. 4% only. Defects caused by normal wear and tear, 12%. By the time you now look at all type of defects that we have in our equipment, again, like I said, what is this? People, human being. Defect caused by human being, 84%. 84%, different from raw material, inferior and correct part. We have a case, the supply chain management people, probably at times, they might not do good PLTC to actually inspect and see that we have correct material. In most cases, it happens like that. So, why are the people in supply chain management? People, human being. The inferior correct part, now my brother is my brother, let him supply it. He has a company, he says, I can help him. The guy go to Aba or go to Lagos Island, go and get one inferior material because he has a brother that is supply chain manager. What are those guys? People. Design flow. The operation at times, we have 21% of this from the design floor. Those are the floor initially, probably it is properly done at the initial stage. What are the people in charge of design? People, human beings. The operating equipment, we have 29%. So our operator have a big role to play in terms of getting to know what the OEM requirements are. This is particular equipment. You have done normally the normal EC that has to be done. You have to check to actually follow what is the OEM requirement in the best way to operate it. So all this one, the workmanship is another one. In the case where maintenance guy, in most facilities, our maintenance manager actually put some subtle pressure. They will not call it "I'm pressurizing you." Instead of saying that. But if you have a particular work order and you are asking a mechanical technician or electrical technician, when can you finish that job? It's a pressure. That's a pressure. You will not allow such a technician to actually do what he's supposed to do. And normally he's supposed to do what he's supposed to do. If there's a failure, a good mechanical technician, a good RE technician, a good control technician will go back to his CMMS to go and check record, go back to OEM record to go and check what is actually supposed to be the cause of this problem, investigate before you go ahead and repair. In most cases, in most occasions, we have a case where we have a failure, our maintenance person want to jump into what actually happened to it. Okay, it's buried. Yeah, we don't keep bearing, put another bearing. It's wrong. All the problem transmitted, you need to have another one. So we should need to investigate what is the actual problem. So workmanship is very key. And how do you know what you're supposed to do? You have to get certified. You have to know what you're supposed to do. You have to know your right from your left. You have to understand why you are doing what you are doing. All these things are very, very key. Yeah, Malam? We have some knowledge posts here.
Okay, let me flash them. Thank you very much so far. Thank you. Let me know if you can see my poll, Aziz.
I cannot see it yet.
Okay,
I can see it now. I can see now.
You can see it now. Okay. Okay, everybody in the house, the poll from our speaker, the first one is ready and it's on your screen. Please vote. Please answer. Only one person has answered out of 56. Okay. 7, 10. Okay. 35 people have voted. There are still more undecided. Please vote. Please vote. Okay, I'm going to stop the poll in 5 seconds. 5, 4, 3, 2, 1, 0. Thank you very much. Okay, Aziz, the results are there on the screen. You can read them.
81% chose true, but 19% chose false. If you look at the question, bad actors procedure intends to identify and remove the organization's highest impact, repetitive or recurring equipment failures. Okay, it is based on equipment design history, and factory acceptance test results. The correct answer is actually false. It is not based on the equipment design history and factory acceptance test result, but rather it is based on the mining of data from CMMS, investigating of various data, analyzing data, and some operating experience from the field operator. So that's the correct answer. The bad actor is the intention is actually correct based on what we have it, is to identify and resolve the organization's highest impact, repetitive or recurring equipment failures. This is correct. But the last one that I had there is not correct.
Okay, thank you. The second poll has gone up. Everybody vote, please. Zero votes. 2, 3, 4, 5, 7, 9, 10, 11, 13, 14, 16, 17, 19, 20, 21, 23, 28. Vote. Vote, please. There are many more people in the class at this time. Vote. I'm going to stop the poll in 5 seconds. That will be 5, 4, 3, 2, 1, 0. Thank you very much. Aziz, over to you.
Yeah, the correct answer there is C, people only. I said it initially when I showed that the person tried to point to people, those elements of reliability. People only, they are the most vulnerable to defects. In design, we have people. Equipment and process, we have people. In the design, we have in process, we have people. Only people are the ones that are most vulnerable to defects. Thank you.
Thank you. The last poll, the last knowledge poll is up now. Please vote. Four, 8, 12, 15, 17, 21, 22, 24, 28, 32, 36, 40. Please vote. Vote, vote, vote. I will stop now in 5 seconds. 5, 4, 3, 2, 1, 0. Thank you. Thank you. Please hang on. Okay, Aziz.
Okay, this is an information. Just 51, majority of people in the house, yeah, partially not in all cases. But we have a significant percentage saying that procedure is new to the organization. Then yes, fully practice. Most likely those are the people in oil and gas. So this is a good information. Thank you.
Thank you. Thank you. Thank you. So that's the end of the poll. You can continue your presentation.
Yeah. Let's move straight to the main event, bad actor and worst actor process. What is bad and worst actor process? Okay. The worst actor identification resolution procedure is an ongoing process. It means that it's a live process, is a process that is continuously done to identify, the problem of our equipment and components, discovering the problem and taking action to eliminate the problem. It's expected to be a major focus of operation and maintenance management because it will mitigate problems which are negatively impacting the operation goal and equipment. So what am I trying to say here? When I say bad data process, is a kind of procedure, is a maintenance strategic procedure put in place to kind of focus on those defects, those problems of equipment, components, or items that are failing repeatedly in our assets, that are continuously failing repeatedly in our assets. Okay, and majorly, it should be a focus of the operation and maintenance management combined. It is not to say that it's supposed to be maintenance people or operation people. It's a focus of both operation and maintenance management because it mitigates problems which at the end of the day, we are going to get some value added to what we do. It's cost effective. If you eliminate problem before it fails, it makes the equipment available for the purpose with which it is designed. And if we have an equipment continuously available and reliable for the purpose with which it's designed, it will go ahead to increase the oil production in our facility. So we use this bad actor and worst actor procedure to actually nail this problem before they fail. Now, the intention is to identify, and resolve the organization's highest impact, repetitive, and recurring equipment failure. I said it before. It is based on analysis of available data and operating experience. If you remember of the poll question, it does not based on the equipment history or factory acceptance test, but rather it is based on analysis of available data, analyze the available data and operating experience in our facility. That is the major intention of bad data and worst actor process. So what do? We performance gaps are identified. We improve upon it. Then we establish a root cause analysis to actually provide some recommendation, for mitigation alternative. Mitigation alternative are selected and executed based on cost benefit analysis. And once this is done, performance is monitored. Okay, these are the major intentions of bad data process. Okay, the repetitive failure we have in our facility, we take note of them. Which component is always fail repeatedly? Which equipment is always fail repeatedly? You do root cause analysis on this equipment, and you get some people that are to monitor it, and at the end of the day, you track it. By tracking it, you know the problem you are facing with it currently. And when you resolve the problem, so because you are tracking it, whatever that is going to be your cost saving on that particular problem is going to be what you have actually spent when you have that problem. Now, what is the scope? What is the focus? And what is the desired outcome? The scope here is to generate bad data leads from the CMS at least every quarter. CMS being authorized maintenance management system. We have JD Oracle in a company, different companies here, they have different type of CMS, different type of software they use for their CMS. But like I said, bad data process, basically you use data, you mine data. You get information from maintenance history of those equipment that you have in the facility. You analyze and validate lists of top actor and select those actors using Pareto chart. Analyze and validate. Very key. Analyze those that you validate. As a reliability engineer, you are kind of the promoter for this particular process. You are the one driving it. You don't want to believe that you have work that. You don't want to believe that those work that they actually have correct code or they have correct problem description. That is why I said they should leave. And always work order for you. It is your responsibility as a maintenance engineer. Look at work order. What is the description like? If it does not have a
Yes, I can hear you now.
yeah. Hello, can you hear me?
Yes, I can hear you now, Aziz. For most of the this slide and the previous slide, I did not hear you, and I'm sure many others did not hear you. Can you go back to the previous slide and start again?
Okay. So this slide is, you mean?
Okay, I think I had here. Then the next slide. Continue from there.
So the scope of bad data process is generate bad data lists from the CMS at least every quarter. You analyze and validate list of top bad actors and select worst actor using Pareto chart. What do I mean by analyze? You have so many of these equipment that have different corrective work order rates on them, but some of them, They don't have correct description of the problem. Like I said, as a maintenance personnel, reliability work mostly with maintenance people. So it is a responsibility of maintenance personnel to actually know what is the actual problem description of this failure. And you are going to know this when you're working in the field. An operator will normally raise a work order to show that this equipment is not performing as designed. It's not performing its duty. It has failed. So what has failed? It is the duty of maintenance personnel to actually look at what has actually failed. Is it the bearing that has failed? And remember, you have to kind of investigate why that bearing failed. So those are the scope of bad actor. And our focus, I mean, 3 or more equipment failures in the past 12 months. Take for instance now, seawater injection pump is a key equipment in oil and gas. So we have electric motor, we have pump. In a pump, we have bearings, we have inboard, we have outboard bearing, so we have seals. All those things are there. So if we have a failure from seawater pump, 3 of it, within 12 months, it means that automatically it's a bad actor. You keep it in a bad actor bucket. Then repeat equipment failure within the past 12 months. Your inboard bearing keep failing every now and then. In the 12 months, in the past 12 months, automatically it's a bad actor. Then any critical equipment failure. Now, equipment criticality is coming to play again now. Gas turbine compressor, gas turbine generator, utility air compressor. These are key equipment to our operation. If you do not have gas turbine compressor performing the way it's supposed to perform, we have a case where we are going to be flaring. What is flaring in oil and gas? Flaring is start to burn the gas. And when you burn the gas, it will kind of pollute the environment. And when you pollute the environment, we have government agencies, DPR, trying to watch out all oil and gas. Are you doing what's supposed to do? It's supposed to be a flare knockout facility. So when you flare, it means you pay some penalty. So if I have a single failure coming from my gas turbine generator, from my gas turbine compressor, utility air compressor, a seawater engine pump, emergency generator, and so on and so forth, it means because it fails one, that means a bad actor. I'll put it in bad actor bucket. Excessive maintenance purchase order. Okay, if I have a case where I have any of my major equipment that has failed, probably I need to replace an electric motor in my emergency generator, and it costs me 45 million naira or excess of $100,000. This is a bad actor. Remember, I didn't say worse. These are all bad actors. Highest impact is CS physics. This is key. The management that they are in charge of kind of managing the cost, what they want to see and what they want to hear, okay, which one can we fix first? So what is the cost? So you should need to manage it in such a way that the one that is the easiest and has highest impact is what you push forward to them. So these are all, don't forget, these are all bad actors. Now, what is the desired outcome? The desired outcomes is to improve the reliability of problem equipment and reduce the amount of corrective maintenance needed. Simple as that. Now, in our next slide, you will see generate bad actor. What are we doing when we are generating bad actors? 3 or more equipment failure in the past 12 months. Remember that. Repeat equipment failure within the past 12 months. Remember that. The excess LPO, lost production opportunity. We have a lot of crude oil right inside the well. The well is right inside the bed of the sea. When you get to the bed of the sea, you dig further. That's where you have the crude oil. Now, those oil are there. But if we have a failure in our facility, for example, now we call it we are asset shut down, we have failure. So if you have a failure that will make us to lose as much as 100,000 barrels or 45 million naira, that failure, the cost of that failure becomes a bad actor automatically. Generated. That's what we use. Energy components. Energy components is another software we have in our facility to track all this. Then the bad actor list will include the following information: equipment criticality rating, number of corrective work orders. Like I said, remember that you are generating this list from CMS. So your CMS, we have all these components in there. Now, gentlemen and ladies, this is where the work of reliability engineers or analysts actually starts from. If you want to have the correct bad actor process that you know that you are getting a good result. You have to actually go into the CMMS, which one is the correct problem, because what we want to focus on is the real failure. The real failure, the FND, that is failure durating, and FSD, failure non-durating. A proactive repair is not a failure. The failure that we discover from a PDM, you are doing a PDM as a reliability analyst. Because of doing that, you find a defect. When you find a defect, there is a work order. The work order, the maintenance guys work on it, actually discover that the job is removed or the defect is removed. Of course, yes, it's been tracked in your settlement, but that is not a defect. That is not a failure. Rather, that is not a failure. So it is not part of what bad actor process is meant to focus on, or rather, those failure. Like I gave an example the other time, you have 3 utility air compressor, 2 units at a time, you have 1 failure. That failure, even though anyone that failed there is failure non-durating, but actually it's a failure. You investigate it. But the other one that actually failed, that has actually made your utility air compressor not available, is not a failure. You investigate that. But your proactive failure from predictive maintenance, those are not failure. Take note of that. So you're going to be sorting all that out. If you don't sort them out, you will not get good results from your analysis. Now, your last list of top bad actor, as I've said, this guy, this is reliability engineer, trying to do some analysis there. Let me take my annotator. Now, you analyze list of bad actor, you use Pareto chart. When you are analyzing the LPO impact, the labor and material cost, the labor hours. The labor hour is the range hour. How many hours? What is the mean time between failure of with which that maintenance guy actually spend while trying to correct the failure? What is the cost of labor? What is the cost of material? What is the LPO impact? You do analysis of all this and use Pareto to actually sort it out. Then the cycle will start whenever there's a vacancy in the worst actor list. So what I'm trying to say now is that vacancy, what is vacancy in the worst actor list? You cannot have all the failure lists on your worst actor list at the same time, but rather you have 5 at a go or 3 at a go, or maximum of 5. In which case you're going to be eliminating them one after the other. You don't want to keep a bogus list in your worst actor, because at the end of the day, you may not be able to achieve anything because you have too many of them. In the course of validating, you have a preliminary list of bad actor, you review in detail using CMS. I've said it before. You check all the code, the cost recorded on work order, you check this, then the LPO, you check this, then you close work order comment. This is another key important message. Maintenance personnel, a mechanical technician, or electrical technician, or instrument technician, control system technician, that are actually saddled with the responsibility of trying to take a maintenance history in CMMS. It is very important. We have what we call PICO in my facility. PICO means P is problem description. You have that at the end of our in the attachment sheet of our CMS. Problem description. You want to have the right problem. Inspection carry out while you are doing your job. The corrective action done. And O is the outcome of your corrective action. If you have a good story of how you met the equipment, what are the things you do on the equipment, including the size of the spanner you use, what is the size of the spanner you put everything in there. You have done a great help for your colleague, either your back-to-back or somebody else that may likely work on that equipment some other time, because it will just go to the history. In getting to the history, you find out everything that has been done in the past and just implement the same thing, make the job so easy. So that is the correct maintenance personnel. So closing work order is very key. You don't want to keep just small information on your work order. You want to give an adequate information as much as possible that can actually help any other person. Even though your supervisor want to see the important job you do. It is not enough to go and work in the field as a maintenance personnel. I've done my work, I've sweat, but your documentation matters a lot. How well are you able to complete your documentation? How well are you able to satisfy your supervisor for him to be able to see what you have done? How well are you able to do your job that will make it easy for your supervisor to place you before other people, during performance evaluation? So all these things very key. What you are putting down as a maintenance personnel is your person, is who you are as a person. So you want to key in correct information in your closing work order comment so that your supervisor will see, your colleague will see, any person in your department or unit will be able to see very well. Then the discrepancies to look for during validation of data. When I've said this, you want to check for multiple work orders. You don't want to see multiple work orders. You want to correct that. Miscoded work orders, you want to remove that. Manual work orders being recorded as monitoring. You want to check this. The clarification from the technician work order comment by reviewing the people. Okay, I've said this problem is better corrected and done. So all these are very key, to get it, because remember I said that bad data process is about data mining. If you are to mine data from CMMS, you have to get the correct data. If you don't get the correct data, the adequate data, it will actually rubbish the result of bad data process. And you'll be doing one thing, the upper management, the local management, will be seeing another thing. So you have to ensure that you have the correct data, the adequate data, to be able to get the accurate result in your bad data process. All these things are very, very key. This is what this picture is saying here. That accuracy, method of application, the process, the rules, all these things are very key. Now, you select what sector. Well, I'm trying to use this picture for this is the what sector among a lot of bad data here. After verifying, you investigate, you look at it, everything. That's what they call a doability matrix. You compare the corrective actions, difficulty. You look at all what you have. Take for instance now, in my gas turbine generator in my first, we have 3 of them, but we need 2 at a go. But anytime that you want to do an offload, you want to sell crude oil, we have 3 of them coming on at the same time. So it means that we need our generator every now and then. What is your worst actor among the lot of your bad actor, among the buckets of bad actor you have, among various failures that you actually have? What is your worst actor? Worst actor is that equipment that you consider that it has a lot of labor impact, material impact, LPO impact. And if you're able to sell your worst actor, to your management, he or she will see really this is a worst actor, and that worst actor become a candidate for you to actually, set people, RCA team that will actually investigate why do we have this failure. The RCA team members have who they call team lead. The team lead will now be one of those supervisors. Remember, I told you that it's something that actually affects the operation and maintenance personnel. At the same time, one of your team lead will be operation supervisor, maintenance supervisor, power control supervisor. It will be an all-inclusive effort. So this is very key. When you now select your worst actor, at the end of the day, you place it in active list. What is active list? Active list is a list which consists of maximum of 5 candidates that are worst actor. Remember, there are a lot of bad actors. Bad actor are those failure that you have in all of those. When I say equipment criticality, there are some failure that at the end of the day, they happen to occur to a C2 equipment. C2 equipment, C3 equipment. There are equipment that are run to failure. If I have a bulb in my facility, do I have to shout because the bulb has failed? No, just take it away. But if bearing in my seawater exhaust pump fail, that means I'm not able to inject enough water into my seawater injection well. If I'm unable to inject enough water into my seawater injection well, what happens to my reservoir? The reservoir will be affected. What is the job of reservoir is to be able to pressurize the well and maintain the pressure. So seawater injection pumps, one of the major jobs that it does for us is to kind of increase the pressure of the reservoir and maintain the pressure. So it's very key. So any failure there is a worst actor. Any failure on my DTG is a worst actor failure. Any failure on my DTC is a worst actor failure. So if I'm able to now put all those in active list, remember, 1 year that you do it, when you do it after 1 year, you track it for another 1 year. As you are tracking it, remember that you have record of everything that has happened to it from CMMS. So this will enable you to be able to actually justify to your boss that this is what you have done in the past 12 years. This is what we are facing before we do a bad data process on this particular failure, but now that we have done a bad data process, this is what we are experiencing, this is the cost saving. Now, talk about this. The worst factor root cause analysis accomplished, okay? Now, at the end of the day, when you have done your worst factor, you have your recommendation, the root cause analysis recommendation, to present them to the management for approval. They have to approve because who pays the piper dictate the thing. You have an idea, you are doing a beautiful job, you have so many things, you are pushing the process, but you need your boss to actually approve what you do. So in trying to get your boss approve what you are happy that you are done, you have your presentation, and you have a recommendation ready. So get to the management, seeking the approval matters a lot. It matters a lot. And I said they actually want to see what is that easiest fix that has highest impact. So whatever that they have approved now, you put it in your tracking system. So tracking system, remember that as you are tracking it, it means that you need to look at those failures again, whether it will happen again or not. So if failure happen again, you recycle them. If it doesn't happen again, you keep that record. So you manage root cause analysis action item to completion, and there should be a leadership champion assigned to action item. I said this one before. Each of these action items, you use leadership champion. You want to involve the maintenance supervisor. You want to involve. If you involve the maintenance supervisor or operations supervisor, it does not actually mean that they will do the job themselves, but you make them responsible for that particular action. And if you make them responsible for that particular action, it means that the job will be done. It means that they are involved. Okay, so that is the importance of trying to make a leadership champion assigned to that action. Then once after list and action item from the beginning plan will be updated. I've said it before. I will say a mitigation plan documentation will be recorded to the equipment record in the CMS. This is very key. This is very important. This RCA record, the recommendation that we have on this particular document, you record it in your CMMS. CMS in my company, we use Oracle JDA, that's what we use. A lot of people here have different type of tools that they use. So whatever information that you have coming from your failure resolution, you attach it to your work order. So what that one do is to make sure that if you leave the unit anytime, your work there will speak for you. Your back-to-back will not be stressed. Your supervisor will not be stressed. During RCA or any investigation on a failure, that particular information attached to that particular work order will help the investigation team. Okay, we have this information, and they actually have a record of what has actually happened to it. All these things are very key. These are part of the reliability package that we have to make sure that we do to ensure that we attain the optimum reliability. Then the next on the slide here is some, like I said, all the proactive work order, so you don't need them. Then upon completion of all action items from the mitigation plan, a worst factor is moved from the action list to the tracking list, where it will continue to be monitored for 12 months to ensure sustained improvement. Underline, continue to monitor, to be monitored for 12 months to ensure sustained improvement. Now, this is about data that you already have. When you are mining the data, you have all the components that you need, the labor, the amount of labor, the material cost, the LPO cost, everything you have in there. But after the worst factor bad data process, you have a case where those equipment, they are not filling again. How do you know? How do you quantify the amount of work you have done? You only quantify the amount of work you have done by going back to history. You know what the company is spending by not implementing a bad data process on such equipment. Now, the equipment has gone, because of the failure, passed through bad data process where you involve everybody. Now, the failure has stopped. You have to get a case where you track all this. So the amount, the total cost saving, the total cost that you have saved, by implementing this bad data process are those costs that you have in your history. You put them together. Since you have monitored it for past 12 months, which is 1 year, those are the things you put in your track record to show to your permanent management, to show to your supervisor that you have seen. Because what you need to do again for feasibility, is to kind of organize the monthly work startup process. Everybody here want to believe with me that reliability analyst or engineer or technology anywhere in the world will face some problem of visibility. Most people don't see what to do. Maintenance guy will believe that what are they doing now is not to spoil and I'll replace it. They don't see. So part of what you need to do to ensure that you make them to see what you do is to organize monthly WhatsApp reports. This monthly WhatsApp report, it can be monthly, it can be quarterly, it can be biannually, depending on how your supervisor wants it. It will enable them to actually see your work, kind of updating them about what you have done, where we are. So in that your report, it will contain a lot of information, including the mean time between failure and cause data. The total cost of resolution for each worst actor will be shown. So the number of successful worst actor resolution with estimated cost saving for both OPEX and LPO will be shown. OPEX means operation expenses and LPO means lost production opportunity. So all these reports will be glaring to them, and then they will now be able to see that the cost that they approved for bad data process, now they are seeing it, it's working for them. They will be happy. If you need to show them again that there's a particular failure that you want to investigate, they will be happy to actually support you. You need support of the management. As the reliability person on board, you need support of your management. You need support of your supervisor. It's very key. And you need the support of everybody working with you. Now, at the end of the day, you have people, the maintenance manager, the operation manager that are listening to me. This is very key. You have people that actually work for you. They have right attitude. They have right attitude. They have correct attitude. They have done them. They have done with what they're supposed to do. They move the job forward. They go through all this process. PDM, they have done it. PM, they have done it. They need to be recognized. Whether you recognize them as a team or you recognize them individually is very, very important. Because the successful is, if they have successfully resolved a particular process, a particular failure that's affecting a particular equipment, it means that it has to be continuous. Apart from salary is always there. Okay, which at times it doesn't motivate people again because it's not right. But recognition in terms of bringing people out where we have a lot of people telling good story about them, everybody is a lot of things to move people ahead in what they do. It is very, very, it will do a lot of very, very help in trying to motivate people. So we have to kind of bring people out and recognize them either as a team or publicly. For successful action item, remove worst actor from the tracking list. So this is where you can now remove worst actor from the tracking list. It will leave the tracking list to a monitoring list. So remember that I said you have 3, 4, or 5, maximum of 5 in your bucket of worst actor list. Now, if you remove 1 or 2 that you have resolved, go back to the bucket of bad actor list, pick another particular failure. Is it still failure that you want to pick? Is it bad failure? Take it to what's called list, the same process, the same team of ROCA team set them up and they look into it and get to the solution and they resolve it. This is just a summary of all the stories so far. This is an incident. Okay, we have data list from CMMS here. This is a computer of a reliability analyst, okay, trying to sort, verify, and analyze and validate here. Okay, before here, the operator, this guy is an operator, he raised a work order. Remember I said it, operator will raise a work order, but maintenance guy will check that work order and ensure, very key, ensure that the problem description is actually the actual problem being faced by that equipment. Then the maintenance guy will secure the work order. You have the reliability guys there with this system, trying to sort, validate, and evaluate. Then come here, erase the team, the bad data team, and select the worst actor. When they select the worst actor, finish here, they take it to the management. When you select your worst actor, management will agree with you that this is actual worst actor. So they want to see you are correct, but they want to actually agree with you that this is the actual worst actor. You need them, so they look at it. They now set our RCA team. This is an worst actor RCA team. They come up with their recommendation. Okay. After the recommendation, you have this guy is the team lead, try to show to the management that this is the result of the resolution of our RCA. So this team and the implementation team performer, they monitor where you monitor the performance of the equipment for 12 months. You have to monitor, like I said, you check all those records. Where are we coming from? Where we are coming from a place, from a stage where we have the labor cost, the material cost, the LPO cost, and this blah, 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 the flaring cost, and this. But now, after implementing this bad data process, we now have a clean record where we don't have, we have low value of LPO, we have very low maintenance cost, we have a very low material cost. So these guys are the one implementing, trying to analyze it. Then the result of all this is to result in good LPO, high production, reduce LPO, reduce incident. If we have reduced incident, we have reduced LPO, lost production opportunity, no incident, automatically we have more of crude oil here. And when we have more of crude oil here, this is where your management will be happy with you. The upper management will be happy with you. The head office, whether your office is based, corporate office is based in Houston or US or France or anywhere in Germany, they will hear about you. Who is that guy that is in charge of this? Because they begin to see high production level. So this is key. Now, a slide is missing here. Let me, excuse me. Sorry. Okay. Yeah, this is the final documentation of, can you hear me?
Yes, I can hear you.
This is the final documentation of all the story. Remember I said it, that whatever you do, if it is not documented, it only means that you have done nothing. So part of your job to actually make yourself visible to people as a reliability analyst on board of any asset is to put all what you do on paper. So this document will summarize everything you have done in terms of the failure that you have resolved on all the equipment. This is a sample that I found online. We use the same thing in our facility. I think it is very good. It has been helpful. At the end of the day, if I present this to my supervisor, he likes it because it summarizes everything I want to see. So what is the equipment number? You have it here. Equipment description. Equipment number, maybe 48200. Equipment description, gas turbine, compressor, you put it here. Equipment location. Where is the location? You put it here. The number of corrective work order, you put everything in here. Okay. Remember, you have mined all this data. You have record of all this data. The same data initially, when you are generating the bad data, you go back to that same data and pull up all this same information, you put it there. Then the bad data analysis. What is the problem description? Okay. Which work group? Maintenance, mechanical, electrical, instruments, we put it here. The bad data validation members, we put their names here. RCA team member, put their names here. Results, we put everything here. They come back to what site of decision, the action item. So those action items that you have during your RCA, you put everything here. The action owner, you put it here. Open supervisor, maintenance supervisor, and so on and so forth. The target date, this is very key. This document is very, very important because it is what you need to have so that you follow through everything you have done as far as this bad data process is concerned. Because if people do not do what they're supposed to do, invariably it will actually affect the process, and when it affects the process, it will not bring out the job. So this is very key. Yeah, at this point, let me quickly summarize the benefits we can get from this bad data process. We have a lot of benefits, that we can derive from this process. Like I said earlier, apart from bad data process, you have so many other. So the benefits here, let me quickly go through the benefits. Fewer unexpected or catastrophic failure of problem area can be anticipated and nailed before they result in failure. This is direct. You give maintenance staff time to schedule repairs and acquire needed parts. And the fewer unexpected and serious failure helping to prevent production stoppages. These are the important benefits. Take faulty equipment offline before your hazardous conditions occur. Build confidence in maintenance schedule, budgeting, and productivity estimate is very, very important benefit. And at the end of the day, it reduces LPO and gas flaring. When we have LPO reduced, because we need high production, and we have reduced gas flaring, Remember, I said when you flare gas, you get penalty. So at the end of the day, these are what I can just bring out as benefit for the purpose of this webinar. We have time constraint. A lot of information about this bad data project. Thank you very much for listening. Thank you very much. I appreciate everything.
Thank you very much, Aziz. We appreciate you greatly. Thank you for spending your time to share knowledge with us. We thank you very profusely. I have learned a lot about this process and how it is used in the oil and gas sector. And I personally like the specific mention that you made severally about making yourself visible and getting management approval for this that you want to do in all industries, across all professions, all roles, whatever you want to do. If it does not have your line manager and top management approval, it comes to null and void. Every time it will come to zero unless you want to use your money to do the project. But if you need management to give you some financial approval, you must be able to convince them. And I also like the emphasis that you made on the fact that every management, irrespective of industry, even if it's an insurance company, a bank, a bottling company, a wood carpentry company, any kind of company, any management will always want the longest uptime and the highest production output of whatever form. That is the kind of language they like to hear. And that's why Aziz mentioned that if you are able to reduce LPO, which is lost production opportunity, everybody will be happy with you, management will be happy with you. So tomorrow if you come and say, I want to do another project to identify a bad actor and eliminate it, they will quickly give you approval because yesterday, the one that you did was very successful and they were able to improve production output by maybe 1%. 1% in oil and gas industry is not small. It's not small volume. It's not small money. It's not small money. Another thing that I took away very well from here in my summary that I wrote down is that he made emphasis, very great emphasis, on getting correct and adequate data. Correct and adequate data. So you must mine data. The data that you mine must be correct and adequate so that you can be able to use them well. Another point he made that resonated very well with me was criticality analysis. Now, this is actually the foundation of risk analysis that we do in maintenance and reliability. If you do not do criticality analysis and you do not do it well, you are unlikely to get the kind of results that you expect, and you are unlikely to get the any clap from top management. If you are running a small operation, small company, where the cost of materials are low, even the cost of your output are low, you can be pardoned if you do not do criticality analysis or if you do them wrongly, because the effect of whatever errors that you make may be very little. But in an industry like the oil and gas sector, everything is expensive. In oil and gas sector, including the people, everything is expensive. So you must do proper criticality analysis to identify assets that are critical to your operation. Important. So across other industries, in the bottling industry, in the telecommunication industry, criticality analysis is very important in managing the assets that you have. It is the foundation of maintenance management, of understanding how you will apply the little scarce resources that you have on the myriad of assets that you have. Sometime in July or maybe early August, we are going to do a webinar class on criticality analysis, and maybe I will host that one. So, but we will do a class on criticality analysis, and then we'll show you all the different tricks in doing criticality analysis. There's no hard and fast rule anyway. It's just the understanding that you need to take away in your head. If you understand how to do the risk analysis, then you can apply it anyhow you want to apply it. So when we do that webinar, I will show you a small criticality analysis that we did some time ago for a particular a part of our process, and we'll explain it. That's all that I wrote down as my summary. Thank you very much, Aziz. That was a very wonderful knowledge share. Those of you in the oil and gas sector will appreciate this very well. There are many terminologies that I've never heard before. I'm just learning them today. So thank you very much, Aziz. Our next webinar that will come sometime in July, we'll fix the date maybe during the week, is from another very good friend of the house. His webinar will be a free webinar. He's also from the oil and gas industry, and he's a very well certified guy in maintenance and reliability. His name is Tamuno Karibo. He's our very good friend, and he will be taking us on the basics of vibration analysis. Vibration analysis is one of the many predictive maintenance technologies that we have available in maintenance and reliability. And this comes under the banner of condition-based maintenance. Anyway, so starting from July, we are going to be going into some specific details, and we'll be starting with this very good friend of ours. He's a reliability engineer with a company called Enaflex in Abu Dhabi. He has worked many years in the oil and gas sector in Nigeria. He was based in Port Harcourt for many years until he relocated to UAE. So join us next week. You will see all our adverts on social media, on WhatsApp. We'll share the adverts, and you will register to join us. Please tell your friends, especially those in the oil and gas industry, those in heavy industries like cement, quarry, those in bottling companies, Nigerian breweries, Guinness, Coca-Cola, and many other food industries. And everywhere you use critical heavy equipment, rotating equipment. Vibration analysis is specifically about rotating equipment. So everywhere you use rotating equipment, especially if they are heavy equipment, then you need knowledge about vibration analysis. The man to do that will be Tamuno Karibo, a very good friend of ours. As usual, this is still on adverts. You can contact us. A few people have contacted us already about this, but it is still running. You can read it when you get the slides in PDF. This is also still running. This is also still running. You can contact us and register. The registration link is already on our website, and we have started the advertisement on our social media handles. This is also still running. As soon as the LMS is ready, we'll put this up, and then all of you can go there to purchase and take the course. We have answered some questions already. The remaining will be answered offline and printed as PDF and sent back to all of you. Our time is well spent, so we will have to leave it at that. You can still drop in some more questions or comments, because after I end this session, I will still leave the platform for like 5-10 minutes for people to drop in as many questions and comments as they will want. So if you want to contact us at any point in time, please, the usual channels are open. After this, gentlemen and ladies, we have come to the end of another session of the BCA Africa webinar series. Thank you very much. If you're on the road, God bless you. Be safe. If you're at home, be safe. Wherever you are, wherever you have joined us from around the world, I say good evening, good afternoon, good morning, My name remains Malam Ibrahim Lawal. Thank you very much, and bye-bye.